All right, so today you should have out your area and volume day 4 note sheet, and we will be working through the examples on it. So you'll be working on those as well as have a calculator in front of you to put things in the calculator. Let me pick an ink color first, and here we go. First example, let R be the region bounded by the graphs of y equals 3x and y equals x squared. We're going to draw a figure, we're going to shade the bounded region, and then we're going to find the area of R. So you should fully expect to get the graph of y equals 3x to be linear and y equals x squared to be a nice quadratic piece. So the part that we're bounding between these two regions is going to be the quadratic piece and then the linear piece. And so our region R is sitting right here. So we're going to find the area of this R. So before we begin, I like to think about sketching a little representative rectangle so that I remember where the roots of this came from. We started finding areas by doing Riemann sums, and so we're going to think about it in the same way. So if we need to find an area of a region, and we know that that rectangle is in the vertical direction, we know that we are going to have the value of our limits from left to right, because everything's going to be in terms of x. And we know we're going to have a length times a width, because that's how the area would be formed for the representative rectangle. We should also know that this width over here of this rectangle, I lost my cursor, the width of my rectangle is the delta x, which then equates over here in my integral to dx. And so we start by trying to figure out where these intersection points are. And I feel like you can pretty much tell what the zero point intersection is. But how would we find this one? Let's say we didn't have a calculator. The calculator is actually analytically thinking about this as when are the y values going to equal one another. So I'm going to set the equations equal to one another. And to solve this, you would get all the x's on one side and set it equal to 0 and factor out a greatest common factor. And then we see that we've got two zeros, one at 0 and one at 3. So the coordinate pair out here has an x value of 3 and a y value of 9, because I can put it into either equation to find the y value. So we're going to from left-hand side 0 to right-hand side 3. Now we need to figure out what the length of our rectangle is. We figured out our width, but our length is going to be whatever the top function is minus the bottom function. So again, top minus bottom, or upper minus lower, sometimes I'll say. So the top function is the linear, and the bottom is the quadratic. And there we are. So finding the area of R, you have a couple of choices. I'm going to do this one by hand to remind us how to integrate, but you could also check your answer with math number 9 right now. So let's integrate 3x and get 3x squared over 2, and integrate x squared and get x cubed over 3. And we're going to not forget our notation that tells us we are about to plug in, using the fundamental theorem, our 3 and then our 1. So that leaves me with two pieces here. The 3 getting plugged in over here should lead me to 27 over 2 minus a 27 over 3. And this would be a 0 over 2 minus a 0 over 3. Great news is that just goes away. And then we combine together the two fractions. I think it's probably easier to think about this is 27 halves and this is 9, because 27 over 3 is 9. And then change the 9 into halves, so I get 27 halves minus 18 halves, which would lead me to 9 over 2, the answer for the area. Next example. The region R is the base of a solid. So we're still going to have the sketch of this region. We're still going to have a quadratic piece. We're still going to have a linear piece. And the base is still this region R. But the key on this problem is that we have a cross section. And the cross section, perpendicular to the x-axis, is an equilateral triangle. So we have to know when we're dealing with volume, let's go back to our days of volume. Back when you took tax and those things, we learned that the volume formula was area of the base times the height. That big B meant area of the base. So area of the base, in this case, is going to relate to that equilateral triangle area. And also for your reference, you should remember and memorize that the area of an equilateral triangle would be root 3 over 4 times side length squared. That's something I'd like you to have in your memory bank. All right, so back up to here. So if we take a cross section that's perpendicular to the x-axis and pull it out from that, this would be like the base of the triangle sitting there. And so if we pulled out that piece, it would be an equilateral piece with side length S and thickness delta x. So if we're talking about volume, we know that we're going to have the area of the base times the height. And we decided that the area of the base in this case, because it's an equilateral triangle, is root 3 over 4 side length squared. And we've been talking about that the height, running off the screen, the thickness there, is going to be dx, or in this case delta x, on the graph, and dx in the integral. So the area of the base is the root 3 over 4 side length squared. I'm going to go ahead and put the root 3 over 4 out in front because he's a constant and I can do that. I'm also going to realize that I'm going to begin and end at the same spot we did in the last problem. At 0 we begin and at 3 we end. Now we just need to have the side length squared. And remember that this right here is that base of this. So that side length should be my upper function minus my lower function, all squared for the side length squared. Again, this was a write but do not evaluate, and that would produce the volume. Third example, we again have the region R, that's the base of a solid. This time, however, our cross-section is a square, and there's a key little phrase up above here, that we're perpendicular to the y-axis, which means that our square piece will go this direction, indicating that the thickness is a change in y. And the reason that's important to realize is because our volume formula, or integral, is going to be in terms of y things. So I'm going to go ahead and put my dy out here to remind myself that everything in here is in terms of y. The limits are in terms of y. The area formula thing will be in terms of y. So again, big base times height. Well, area of a square should be side length squared. You learned that back in your pre-algebra days. And again, if I pulled this out, it would make a nice little square cross-section with that piece sitting in that region right there. So in this case, instead of starting at 0 and ending at 3, we're going to start at y equals 0 and end at y equals 9, because everything's in terms of y. Now our side length squared in this case will be this quadratic function minus the linear function. But the problem is our right function, because we're going to do right minus left, our right minus left, we just realized, would be our quadratic minus our linear. I cannot write here x squared minus 3x. Why not? I cannot because we need these to not be x's. They need to be y's. So I'm going to have to think about my two functions. One of them is y equals x squared, and one of them is y equals 3x. So I need to solve them for x. This one is x equals plus or minus root of y, and this one's x equals y over 3. We'll use the positive portion because we're in quadrant 1. Again, we want quadratic piece. Quadratic piece is either this first piece if we're in terms of x, or this piece if we're in terms of y. And so I pick the in terms of y positive quadrant 1 piece, minus, again, the right-hand function was the quadratic and the left hand is the linear. And we decided that the linear one, how we're going to write it for this integrand, is going to be y over 3. And then we're done. We've got volume. And again, we're writing but not evaluating. If you were entering this in the calculator, you would just enter in x's because it's fine at that point once you've set up the integral correctly. Right, you should now have an assignment, or several assignments to finish, and also a homework day 4 that's attached on the website.